Oh, hey, thank you. Thank you. All right. Okay, thanks very much. Well, let's do this properly. And I'll start with a really, really quick accordion number, and then we'll get right into the XZ hack. Darling, you got to let me know. Should I sleep or should I code? If I sleep, I'll miss the milestone. And if I code, I'll break my head bone. So come on and let me know. Should I sleep or should I code? Thanks so much. So, in the spirit of making it accessible, and also because I do not actually do security work as my main gig, I'm going to keep this as intro and beginner level friendly as possible. So you do not have to be a member of the Neon Temple to understand what I'm explaining. And in fact, I'm going to explain a few other things that might actually give you a little bit of extra computer science knowledge. So this is going to be fun. This is going to be beginner friendly, and yeah, none of this is going to be deep arcane stuff. But you will understand a little bit more about security after this. So, anyways, to begin with, yeah, I'm Joey DeVilla. I've done a whole bunch of things. So I am, officially as of Monday, I'm the developer relations guy at a company called Unified. Unified is basically a unified API company. Instead of having to call 12 different APIs to build an application, especially a SaaS application for business, you only have to call one. And you will never, ever have to directly connect to Salesforce again. That alone makes it worth the money. All right. Okay. The other thing is, along with Anitra, who is in the lime green leopard skin jacket there, I run a couple of, she's my wife, and we run a couple of meetups together. One, of course, is the Tampa Bay AI meetup. The other one is Coders, Creatives, and Craft Beer. That's all conversations, no presentations. It's just a fun meetup. We are organizing one. There is a new vampire-themed bar downtown, Dracula's Legacy. That's where we're holding it, because that's going to be a hilarious place. There is a giant bat throne. There are pictures of Count Dracula everywhere. It's going to be a fun bar to have a meetup in. And the slides are available at globalnerdy.com/bsides-xz if you want to follow along or look at it later. And I'm actually going to update those slides because the XZ backdoor is an ongoing thing. We only generally found out about it last week. And really quickly, the other thing I do is on my personal tech blog, Global Nerdy. This is one I do on my own, not for any employer. I publish a weekly list of Tampa Bay tech events. Go check it out. And basically, it was a job search tactic that went wrong. What happened was, when I was looking for a job, I thought, I'll present myself as a community guy, and I'll put together a weekly community list. My plan was to stop publishing it after I got the job. But the minute I did, everybody was going, where's the list? I want it back. So I just decided, well, let's do a community service. Let's keep doing it. Now, keep that in mind, because that's actually going to be a factor in the hack I'm going to discuss, this whole community thing. All right, and once again, yeah, quick plug, because I am newly employed by this company, and I need to let me know, because I have to send this to my boss. And I have to say, look, I'm worth the money you're paying me. Thank you for hiring me during the great layoff season. And yeah, it's at unified.to. So anyways, let's talk about Vecna. Who here has seen the most recent season of Stranger Things? Okay. Who here grew up in the 80s? Actually, is the other thing. So some of you grew up in the 80s. There are a lot of people who actually thought that Dungeons & Dragons was a game they made up for the show and not a real-life game. But D&D has been around since the 1970s. A bunch of nerds in Wisconsin who wanted to play Let's Pretend with the Hobbit with dice decided, let's make a game, and they called it Dungeons and Dragons. And Vecna is actually one of the oldest characters from the Dungeons and Dragons game. And Vecna, and the important thing about Dungeons and Dragons is it is a formative part of being in technology. If you are in tech and you have not yet played Dungeons and Dragons, go play Dungeons and Dragons, or at the very least, if you play video games, go get the Baldur's Gate game, because that's D&D in video form. But yeah, by all means, Reid Hoffman, the founder of LinkedIn, actually creates his success at tech to being a D&D player. And yes, Vecna is a lich. And a lich basically is just somebody who wants to live forever and is a wizard or a cleric or some kind of magic user who decided through a combination of magic and sheer force of will, I want to live forever and be evil forever. And Vecna is one of these. And in fact, there are a couple of artifacts. This is from the old school. Let me see if I can't find it here. 1980s, actually 1979 edition of the Dungeon Master's Guide from Advanced Dungeons and Dragons. The rules are quite different now. These are the old school rules. This is the text from the old school rules. There are a couple of treasures that you can get, but they carry terrible prices. One is the Eye of Vecna. It is a magic eye that used to belong to Vecna. It is a piece of treasure. You actually have to get a spoon and scoop out your own eye to put in the Eye of Vecna. It gives you great powers, but at a great price. There is also the Hand of Vecna, which is Vecna's severed hand. You have to chop off your own hand and then graft on. Just actually hold the Hand of Vecna to the stump where your hand used to be. It will magically attach. It will give you superpowers, but at a price. And this is actually also related to the topic that I'm going to talk about. And the topic I'm going to talk about actually has a formal name. It is CVE 2024-3094. It is otherwise known as the XZ backdoor. And had it been successful, had it not been caught by one person who was just running some tests and noticed something weird and actually decided, instead of saying, so weird things happen all the time, you know, I'll just deal with it, because he's in San Francisco. Weird things happen all the time there anyway. But he actually looked into it, and that's how he found out what was going on. And this is what we're going to discuss. Now, the security vulnerability in XZ is a backdoor. And a backdoor is very similar to a portal to the upside down. And a backdoor basically is a way into a piece of software that bypasses the normal authorization or some kind of security protocol. Now, backdoors aren't always all bad. If you've ever had to talk to tech support or because somehow you got locked out of your own account, or there are times when, of course, you know, people are going to forget their passwords. I once had to help somebody actually at an advertising agency because he was maintaining this mail server. They had a completely numerical password, and somebody decided to prank him. When he was logging in to maintain the mail server, some guy just started yelling out random numbers. And for some reason, he completely forgot the password. So they had to call me in. I had backdoor access to the service, and that's what allowed me to actually let him into the service so he could reset his password and do his own things. A backdoor allows you to do administrative things, and it is a necessary thing, but it is also a way. It doesn't just let the good guys in. It will also let people with bad intent or people who are completely unauthorized and not allowed to do anything in that system to hop in. And bad backdoors are backdoors that are installed often without the knowledge of the people who own the system or who are authorized to run the system. And they're generally there to allow an unauthorized party to perform one of the 4 S's, as I like to call it. Spy, which basically means look into the system and look at information they're not allowed to access. Steal. This is more than just copying information. This is possibly performing financial crimes. Subvert, which means basically either take over the system to do something you want or prevent the owners of the system from doing something you don't want them to do. And of course, sabotage. Just completely mess up the system, take out anybody's capability to use that system for its intended purpose. And that's what bad backdoors are for, and that is what got installed into a utility called XZ, which is in every Unix system. That includes macOS. And I have a little bit of experience with backdoors because I'm friends with the people at the Cult of the Dead Cow. They are the OG hacker group. They have been around since 1984. That is my friend Death Veggie there. That's at DEF CON 8, 2000, so it's a little while back. And Cult of the Dead Cow members clean up really well and end up in really, really high places. That is Mudge, aka Peter Zatko. The photo is him on the left in 1995 when he was a guitar student at the Berklee School of Music. And that 2011 photo is him at DARPA in charge of President Obama's cybersecurity community. So you can go places, even if you did only 3 years playing guitar at the Berklee School of Music. Okay? This other guy here, we used to know as psychedelic warlord, and later on when I found out he was running for Congress in Texas, I was going, wait a minute, psychedelic warlord? Oh, he cleans up real well. I was just going, I never would have guessed that's the same guy, but that's Beto O'Rourke. So he is also a Cult of the Dead Cow member. And if you want to learn more about the CDC, Cult of the Dead Cow, there's a fantastic book by Joseph Menn. He talked to all the original members of the Cult of the Dead Cow, including guys with handles like Kevin, Grandmaster Rat, there is Sir Distic, and then there's my favorite handle, Dildog. And the Cult of the Dead Cow did make a famous backdoor called Back Orifice. In fact, they made two versions. They made Back Orifice 98 for Windows 98, and then they made Back Orifice 2000, which would run on Windows 2000, which would run not just on Windows 98, but Windows NT and Windows 2000. And this was around the same time that a young guy was trying to convince PayPal to switch from totally insecure Linux to way more secure Windows NT. And he got kicked out of that company. That guy was Elon Musk. The company was PayPal. Yeah, had they done that, the Cult of the Dead Cow would have totally owned PayPal. So good call on just letting him go and sticking with Linux. So XZ is totally wizard, graybeard, Unix stuff. You are not likely to use it directly. In fact, you are probably more likely, if you use it at all, you're probably going to use it as part of an argument, as part of the capital J argument in the tar command. And I'll talk about tar a little bit later on. But basically, it is for doing file compression. And it is primarily in what they call POSIX systems, which is a fancy term for Unixy things. So anyways, that means Linux distributions, and yes, Mac OS. If you have your Mac right now, you can open Terminal and type in XZ space -- version, and you can see if you have XZ, and if you do, what version you're running. And that'll be a little bit more important later. But, all right, I mentioned tar, and of course, I have to talk about tar. Tar, for those of you who don't know that it's short for something, tar is short for tape archive. And basically, it has just one purpose, to take a bunch of files and just gather them all into a single file that you can refer to by a single name. That is it. It does not do compression. You run a separate program to take a tar file and then compress it. But yes, tape archive, it's called tar for a couple of reasons. One, you have to remember that this is Unix was made in the era when you were talking to a remote computer over a 300 baud modem, which is really, really slow. That means 300 bits a second, and you have to remember at the time, a character took up 8 bits. So and characters take up 64 bits today with Unicode. So anyways, it was slow, so the idea was keep Unix commands short. And of course, tar was for tape archive backup or backup to magnetic tape, which at this point somebody's going to go, OMG, WTF is magnetic tape. And I will tell you, Gen Z, it is a way we used to store data. Actually, it still is a way to store data because it is still space efficient. You can store piles of data on it. It will last longer than any hard drive, and yeah, definitely. And it will, if you put it in the right kind of case, it will survive a fire. And of course, you don't. When you put it in storage, you don't have to keep it plugged in, and you don't have to keep it attached to power. And it's got a lifetime. They say 30 years if you take really good care of it. Maybe 60 years. The DVD-ROMs you buy these days as backup may rot within 2 years. So tape is still a useful thing. And in fact, there is such a thing. If you are new to Unix, if you've been living in the Windows or Mac world for a while, you may have heard but not know what a tarball is. And a tarball basically is simply a tar file that has been compressed. That is it. But tarballs are a very common thing that we use, especially in the Unixy world, for moving around what is called object code. And I will tell you what that is. Don't worry, I keep saying I will tell you what that is later, but I promise you, I will tell you and you will find out. But to make a tarball, you have to do compression. And a lot of people actually don't know how compression is. So what I'm going to do is I'm going to show you the world's dumbest compression algorithm, but it will give you a general idea of what's happening with compression. So the first rule about computers is that everything in a computer is a number. Every character you type in is represented by a blob of Unicode, and that is 32 to 64 bits, but it is a number. Every pixel on the screen is a number. So what I'm going to do right here is, let me show you this. This is a very simple picture. It's just 16 pixels, 4 by 4, and they're all orange. And let's say I've just decided that the number 5 is going to represent the color orange. So I can represent these 16 pixels with this array right here, 16 5s. That's it. So this picture takes 16 numbers to represent. Now, all compression algorithms try and take advantage of repetition. So my dumb compression algorithm says, I'm going to represent pixels, lines of pixels by groups of numbers. An ordered pair where the first number is the number of the color and the second number is the number of pixels. So basically what I did was I just took 16 pixels worth of information, 16 numbers, and I squashed them down to 2. And that's an 87.5% size reduction. I'm going, oh, this is great. Now, a picture that is all orange is kind of boring. So I'm just going, all right, well, what happens if I do this? I'm going to make 10 of the pixels green after the first 5 pixels. I can still represent that with 4 numbers, 2 ordered pairs, the first one representing the first 6 orange pixels, and then the second number representing the 10 remaining green pixels. I'm only using 4 numbers instead of 16, so I've still compressed my file by 75%. Now, the compression algorithm gets less good the fancier the image does. This time what I'm doing is I'm just going, okay, I'm now representing 3 runs of colors, some orange, some green, and some pink, and I now need 3 ordered pairs, 6 digits, but I'm still compressing the thing by almost 2/3. So far, so good. And in fact, let's say I introduce 1 stray white pixel at the end. I now need 4 ordered pairs, 8 numbers instead of 16, but I've still compressed the file to half its size. So I'm going, okay, the compression algorithm gets a little worse the fancier the image gets. And in fact, if I go with a picture like this, this is where my compression algorithm falls apart, and this is where many compression algorithms fall apart. Each of these pixels is different for each one, right? It keeps changing. There is no continuous repetition of each. I'm using two numbers to represent a single pixel, and I have to do it all 16 times. I've actually expanded. I have doubled the size of the file. And this is what happens when you try to compress a JPEG. JPEG files are already compressed. And when you try to compress it, you are actually adding more additional information instead of taking away information. And that's why JPEGs get larger when you try to compress them. Now, what I am doing right now is called lossless compression. I am making sure that I can reconstruct the image here perfectly. Now, let's go back here. Let's say I say, you know what, this is just one white pixel. Nobody's going to notice. I'm going to compress it like this, all right? I've lost information, and when I reconstitute the information using these 3 numbers instead of the actual 4 numbers, yeah, I don't get an exact copy. It's close, and for some purposes, that's good enough. For pictures, most of us, we don't care about the occasional stray pixel, but that is lossy compression. So that's the difference. Now, the reason I'm going into all this, of course, is that XZ is a compression algorithm, and we use it to actually transmit large files, usually for system updates. This is how XZ works. It's a little bit fancier than the world's dumbest compression algorithm that I showed you, but it does pretty much the same thing. It takes advantage of repetition in data and then goes, okay, I don't have to repeat that data, so I will use this repetition so I don't have to copy as much information. That is the spirit of compression. And it is based, now XZ used to be known as LZMA, and LZMA is short for Lempel-Ziv-Markov algorithm. Markov is basically the guy who came up with Markov chains, which talks about randomly moving from one state to another. And Lempel and Ziv were 2 math guys who just figured out how to take things like Huffman encoding and turn it into compression. There is a dark science behind compression. It requires a lot of math. And despite the fact that I was an electrical engineering major, it is math I don't want to bother with. So I'm just happy to go and use something called the LZMA library and go, you know, whenever I need compression, I'm going to use the built-in functions that are in that library that are available in just about every Unixy system because somebody has done the math for me. I'm trying to write an application. I'm not trying to solve math equations. And this is how you actually use tar with XZ. Typically what happens is you almost never use the XZ command itself. You use the tar command followed by, remember this is Unix, you usually put the options after a dash immediately after the command, and it's the capital J that says, hey, by the way, while you are creating the tar file, compress it using XZ. And then you say, and when you've compressed it, I want it to go into this file, and I've given the resulting file the name tarball.tar.xz, and the files that I want to compress, I just list afterwards. This is a very common thing. Lots of sysadmins do this every day on Unixy systems. Now, the problem with XZ is it's compression. It's not sexy. It's not fun. It's really hard to get a developer to do it for fun. Normally, this is why we actually pay developers a lot of money. It's because a lot of the stuff we do is just downright boring, and we would never do it otherwise. And yes, there's always a fad right now, and there's always the hot new thing, and every developer wants to be an AI right now, yada, yada, yada. The problem is, XZ is boring as all hell. And have any of you seen this XCD cartoon? Yes. Okay. This is very important right here. This random person in Nebraska who has been thanklessly maintaining it since 2003. I thought this was, well, actually, a lot of us thought this was an exaggeration. But replace Nebraska with Finland and replace 2003 with 2005, and you get this poor guy. This is Lasse Collin. He is Finnish. And he is XZ's lone maintainer, or he was XZ's lone maintainer. He was experiencing a lot of burnout. This is his GitHub commit list. There is no shame in this, all right? From my old company, I actually have a very big green GitHub commit list, but this was as an employee of Okta. On my personal list, there's not that much, because I was just going, well, you know what, I want to do other things aside from code. But Lasse was experiencing a lot of burnout. And of course, he had been maintaining XZ alone and all the XZ versions, which includes XZ written for C, the XZ port for Java, the XZ port for various system architectures. And yes, he was experiencing burnout. So, enter this person who's going, and I have to put their name in quotes because we don't know if this is their real name. Jiatan creates a GitHub account in 2021. Has an email address that is, has one of these email address that is name, 3 digits at a vague email hosting company. Creates an account. This account is still active but suspended. Jiatan contributes a lot of stuff. And November 2021 makes a pull request for libarchive. Now, for those of you who are not familiar with GitHub, a pull request basically is, hey, I have a correction or I have an enhancement to this code. Take a look, and if you like it, you can add it to the main code. And the code that he wanted to make a contribution to is something called libarchive, which is a C library for archiving and compressing files. It's a very nice, friendly, positive, open source thing. This is what Richard Stallman and Eric Raymond talk about. Let's see, I'm missing a. Okay, actually, I'm missing. I'm missing a slide here. No, I'm not. But okay, positive contribution. Let's go with that. But he makes a commitment to XZ a little bit later on. This is C code, and basically what he's doing here is it's a simple thing. He just adds an if statement. Anybody here code in C? Or JavaScript? Oh, okay, all right, perfect, all right. It's an if statement just to check if the parameter for these two functions, LZMA, LZMA props, and LZMA, LZMA2 props, okay, one of the parameters to that function is a void pointer. For those of you who don't program in C, a void pointer is a pointer to any address anywhere in the system. He just added code just to return an error code if somebody gives that function, fails to give that function an address for that pointer. Because if you try to access something with a pointer that has not been initialized, you get this. And anyways, he submits this, and the problem with some pull requests is that a lot of people just kind of review them really quickly, especially if it's a volunteer thing, and they just go, LGTM, looks good to me. In fact, you'll see, do a search on GitHub sometime for the letters LGTM, like that. You will see lots of commits that get pull reviews that get accepted with just LGTM. Very quick review. And one thing he did was, Jiatan later on filed a pull request that he said did one thing, but did something else entirely. And the one that he said, I'm fixing some weird error messages. What he actually did was he replaced a print function, a good safe print function. Actually, it has safe in the name, safe fprintf, for safe formatted printing. It's very good at handling control characters and invisible characters versus the old thing, fprintf. So basically, he downgraded the safety on one package, which is like And basically, it's like kind of trying to serve off-brand potato chips, which is why I have prongles here. All right. Now, hang on just a sec. Let me step back. I have hit the wrong button here. OK, so what I'm showing you now are emails being sent to the XZ maintainer. Now, here's the thing. You know, this is around 2022. Lasse Collin, the XZ maintainer, is feeling burned out. And people are going, hey, is XZ? People are now harassing him. Why haven't you maintained this? Why aren't you updating this? So there's this guy who goes, yeah, hasn't been updated in over a year. And Lasse goes back and goes, you know what? I'm really busy. I can't take care of this all the time. But development is ongoing, I promise you. And this really helpful guy, Jiatan, has been contributing to the code. You know, so I'm hoping I can get some help from them, whoever they are. You know, they seem all right. And then this dickhead comes on. And basically goes, yeah, you know what? You don't care anymore. You're not doing this. All right? Jigar Kumar also has an email address that is jkumar, 3 digits, at generic hosting company. Doesn't really have much of a net presence prior to this email exchange. Keep that in mind. Lasse responds back and says, and does something that is a bad thing to do from a security point of view. He told the truth. He actually said, I've got some ongoing mental health issues. I'm trying to take care of this. Please remember, this is a passion project. Dickheads are going to dickhead, and this is how Jigar responds. So now there's pressure, you know. And then the more reasonable guy makes what looks like a reasonable-looking suggestion. I'm sorry about your mental health issues, but in a kind of a passive-aggressive way, maybe you can pass maintainership of the project to somebody else. A little bit of pressure there. And Lasse basically says, you know, I got to be careful about finding a co-maintainer, you know. While I am busy, this is an important project. There are systems that do rely on this compression algorithm. And he explains later on, yes, as I may have hinted, you know what, this Jiatan guy, he's made some contributions. He's been solidly helping. Maybe I will hand it over to him. So on November 30th, 2022, 2 things happen. This one takes all the air out of the room. This one is what everybody's talking about. But the other thing that happens is that Lasse Collin updates the bug reports email for the XZ project and makes an alias that sends mail to both him and Jiatan. And at the beginning of 2023, Lasse releases his last version, after which the new maintainer, Jiatan, releases the next version of XZ. From this point on, Jiatan is running the project, the helpful guy who swooped in at the right moment when people were coming down hard on the original maintainer. And then Jia makes a set of small, innocuous-looking changes. And he opens a page request in OSS fuzz. Now, fuzzing basically is the process of basically feeding all kinds of garbage input into a system to see if it crashes or if it responds incorrectly. OSS fuzz is an open source fuzzing utility. And in fact, here is an example of fuzzing right here. A tester walks into a bar and orders -1 beers, QXY, you know. Orders in Klingon, actually. Yeah, that's Klingon there, right beside the Hebrew. All right? So that's what fuzzing is. But he futzed. He OSS futzed with OSS fuzz. He actually disabled the use of a function that would allow OSS fuzz to detect what he was about to do to XZ. And he submitted it. He submitted it as a page request, but he said, I'm fixing some weird error messages. But what he actually did was he disabled a particular part of the safety system. And then he adds an ignore file. He adds a file, sorry, to the git ignore file. And for those of you who are not familiar with git ignore, yes?
How long was it between those two?
Let's see, February and actually, oh, I forgot to date that one. That's about January. That's about a month before.
Okay.
So a month before, he futzes OSS fuzz, and then, yeah, a month later, he adds a specific file to git ignore. Git ignore basically is where you list all the files you don't want checked into source control. And one file he adds to git ignore is called build-to-host.m4. An M4 file is a macro file, and you normally ignore it. Basically, it's a build file. And while he removed it from the open source repository, he included it in the distribution packages for XZ. So there would be no way for anybody to actually look at what that particular M4 file does. And nobody would care. It's a configuration file. It's not the main code. Nobody pays attention to that. So February 23, 2024. We know this only by a lot of security people looking at his GitHub commit history. He adds a couple of files to the tests directory. And these are test files for compression. Who's going to look at that? And nobody even looks at test files anyways. They're just for testing the main program. They're not what the program is about. So clever. Test files, these are large binary objects. They look like this. Here's the thing, all right? Normally, when you compile a program, you write your code, you run it through the preprocessor and the compiler. That produces assembly language. Assembly language is closer to the machine, but the machine can't understand it yet. You have to run it through the assembler to get code that the machine understands. But you may need to use other libraries, basically code other people wrote. What you do, and in order to use them, you need to take your assembly code, your object code, and link it with those libraries, and that's handled by the linker, and that's how you get the application. So that binary test file actually contains object code, but it was hidden. It was actually not just, they did a little bit of math so it didn't look like machine code, but then what they did was inside this test file, they took that object code and split it up into pieces. So they broke it up so that they'd read 1,024 bytes, skip the next 2,048 bytes, read the next 1,024 bytes. But basically, this code was just broken into pieces, just the way some people sometimes disassemble a gun into tiny pieces and hide the parts all over their house. So what happened was that M4 file, which was hidden from source control, but part of the distribution, when you compiled the new version of XZ, took the evil object code, created this little library here, which the XZ compression uses, and then created a new poisoned, effed around version of XZ with. Now, XZ installs this new poisoned liblzma library. This is the thing that actually knows how to do the compression. The liblzma library, because it is part of, because it's a compression utility and it's often used by the operating system, got hooked into by systemd. The system daemon, Unix users will know this as process ID number 1. It is the main thing that runs the entire show. It is the ringleader of a Unix process every time you start up a system. And systemd, of course, has access to SSH, which is secure shell, which is a way to securely contact a computer. So really quickly, the way you contact a secure shell, of course, is you need a private key. I'm going to skip this bit, but basically, if you download the files, this is the easiest way to explain private keys and public keys. But basically, what I'm saying is that if you have the private key for an SSH server, and you happen to know where that SSH server is, you can log into that system and log in as root. Now, how disaster was averted? Remember Murray from Stranger Things? Sort of the secret hero? Okay, a guy from Microsoft, of all places, working on PostgreSQL, of all databases, handed in this message. Basically, long story short, he was going, SSHing into a system for Postgres is now taking a ridiculously long amount of time, but we're not talking that really long. We're talking on the order of 30 to 40 milliseconds. You would never notice this. And he's going, but I remember somebody was having the exact same problem with Valgrind, which is another Unix utility, and he's going, I need to look into this. And that's when he started finding out, wait a minute, what's going on here? Something is allowing somebody to SSH in with some private key that we don't even know to log in and basically log into any arbitrary system that has this version of XC as root. This would have compromised millions of servers. Most of them public or enterprise servers, or things that run utilities, including water, electricity, fuel supply, etc. And of course, this Jiatan guy who slowly took over the XE library had to do it over 2 years. They were playing the long game, doing the long con, which makes us wonder, is there a nation state? And a lot of people, the three main suspects are China, naughty Korea, not nice Korea. There's naughty Korea and nice Korea. Glorious leader is Lee Tak-sor. Or maybe the not-so-former Soviet Union. And that's what they've been throwing around. I think right now there are some hackers who are saying APT 20. Is it 28? One of the bears. There's Fancy Bear, there's Careful Bear, there's a whole, but of course this is all speculation at this point. But the first thing we need to know now is that this is no longer the 1990s. We're going to, if we're going to get people to contribute to open source projects, we need to get better at vetting them. This is not the Wild West anymore. This is a different world from when open source first made its big rise to prominence, and we have to be careful about that kind of thing. The other thing is that open source is no guarantee. Open source is good. I don't want to poop all over open source, but it is no guarantee that it is secure. The line with many eyes, all bugs are shallow only works when many eyes are actually paying attention and not when it's just one lone person in Finland working by themselves in their spare time writing a utility that major systems use all over the world. So like I said, not the 90s anymore. And remember this. This has become the world's most relevant cartoon as of today. And that's it. Thank you very much. Are there any questions? I'll answer them as best I can. Yes?
So open source, by definition, is completely distributed. So how do you enforce the suggestion that you made to have open source developers have better understanding and control of who's participating in the development?
Unfortunately, the way to do that is also to take the open source approach and distribute that training. But luckily, with open source, what happens is there tend to be some leaders that people look towards, and then they emulate those leaders. Basically, what we're going to need to do is we're going to need to find the open source leaders that are out there today to come up with a way to propagate better processes. Just as, you know what, there was no sense of pull requests until GitHub made it popular.
Can you shut up for a second, please?
Yeah. Oh, sorry. So GitHub actually created some de facto processes that we now kind of accept as standard, like pull requests. That's that didn't exist before systems like GitHub. So we're going to need to create these de facto systems as well. I think I could take a couple more.
Can you repeat the question whenever it's asked?
Oh yes, sure.
We'll definitely want to record it.
Okay, perfect.
Do you have a list of other Nebraska
Do I have a list of other Nebraska-like utilities? I don't, but I believe somebody does, because I'm sure that cartoon scared enough people into compiling a list like that. I should try and find it, but I will update the slides for that. Yes?
Maybe it's just me, but I'm always just curious about everything. So the fact that a PR could have been merged in without actually looking at every single file. I mean, I understand people maybe don't have time. Maybe I find myself with a lot more time and a lot more curiosity, but that part feels interesting to me. So I guess the takeaway would be to always be curious about what's in a PR, even if you think it's benign.
Oh yeah, always be, the question is, how could this have happened with a PR and somebody not looking? And my answer basically is security falls apart when somebody fails to do the necessary legwork. And one of the tricks that that people use to get people to skip that legwork is to use time pressure. So remember that email chain? That was that was probably one party. If it may have been several, it may have looked like several people, but it was probably one paying party being paid to add pressure to the maintainer to make so that they would make less informed decisions or skip things they normally would.
I think I forget now, because he put that in after he got commit access. So I don't think that needed to actually go through anyone's eyes.
Yes, but basically what he did was he established trust. Yeah. And that is the important thing, is that you establish trust so you can betray them later.
We may have to take some in the back, though, because
okay.
we got to set up for the next one.
Yeah, got to set up for the next one. I'll be out in the hallway to answer more questions, but thank you very much, and thank you, B-Sides.